Velocity time graphs. Here we have a graph of velocity in meters per second on the y-axis against time in seconds on the x-axis. From A to B we have a straight line showing a constant acceleration. The acceleration is given by the gradient of the graph, which is the change in the y value divided by the change in the x value. So we can find 10 meters per second in 2 seconds gives an acceleration of 5 meters per second squared. From B to C we have a horizontal line showing that the velocity hasn't changed. We have a constant velocity of 10 meters per second. C to D has a straight diagonal line with a steeper gradient than from A to B. This is a constant acceleration. We can find the value from 20 meters per second divided by 2 seconds gives an acceleration of 10 meters per second squared. From D to E, the velocity keeps increasing, but the gradient and therefore the acceleration is reducing. So we have a reducing acceleration. The gradient of a velocity time graph gives acceleration. Here we have another graph, and here we have a low gradient showing a small acceleration, a large acceleration with a steeper gradient, levelling off to give a constant velocity. To find the acceleration at a certain point on a curve, we first draw a tangent with the same gradient as the curve at that point. So at 4 seconds, for instance, we draw a straight line that is as steep as the curve is at 4 seconds. Make the triangle as large as possible and find the gradient of the tangent. So we have a change in velocity of 36 meters per second in a time of 4 seconds. This gives an acceleration of 36 over 4, which is 9 meters per second squared. Here we have our original velocity time graph again, and this rectangle here, the area of that would be given by a velocity of 10 meters per second times a time of 2 seconds. So the area of the rectangle comes out at 20 meters. The area under a velocity time graph gives the distance travelled. If we wanted to work out the distance travelled in this section, we have the area of the triangle, which is half times the base times the height. If we wanted to work out the area under this section of the graph, we might have to count squares or estimate the area.